So our company introduction, we're founded and based in San Francisco. Right now we have around 13 employees. Expertise is in kind of hardware and software development. Won some awards. And I'll just get straight into basically some of the challenges that we face so far. But I just want to clear up any questions. Does anybody have any other questions about what we do or how we do? Because I'm going to get pretty into detail about our challenges. No? All right, cool. All right, so I'll talk about Bluetooth especially today because our experience is a lot with Bluetooth. Can I ask how many people have worked with Bluetooth? Okay, so around 4, 5, 6 people. All right, so Bluetooth itself, if you've ever worked with Bluetooth, regardless if you're using app or if you're actually doing the hardware aspect of it, or you're using, there's two different roles in it, there's central and there's peripheral. You'll know that there's a host of challenges that come with doing Bluetooth development. And so one of the things that we ran into, one of the challenges was always when it came to interfacing with the customer itself, because we actually use the phone to actually communicate with this as well. But, so a lot of people, I'll also start by saying this, a lot of people say, you know, why don't you just use the phone to do this? Why can't software replace this? And that's a very, very common question we get. I wouldn't be surprised if you guys had this question as well. The very simple, well, there's a lot of answers to this question, but mobile apps themselves, you have to realize that they're kind of like small computers within your pocket, right? And as such, small computers, there's a lot of programs on it, there's a lot of things that are standby, there's a lot of things that are running, there's a lot of things trying to grab the core CPU's attention, you know, trying to run their own processes. So it's a very big challenge for you to have something dedicated that's dedicated for wireless technology, that you're always trying to reach out, always trying to communicate with the outside world. So one of the challenges that we faced when we were trying to interface this thing with the phone regarding specifically iOS is iOS loves to go into power saving mode. Anything that it can kill, it will kill. And so this presented a lot of challenges for us, such as when we wanted the phone to start scanning for nearby beacons, nearby peripherals. For some reason, not documented whatsoever, wherever in the Apple documentation, the phone itself would start scanning slower. And then we only realized this through experience when we started scanning. We started counting as like how many advertisements am I getting in the phone, and then it starts slowing down, slowing down, slowing down. So it's a big challenge in working with these kind of third-party software platforms because you really don't have much control over the actual behavior of the device. This, however, we do, right? So when you have a dedicated device like this, you can just hand out to different people, and they come in. There's no buy-in at all. You don't have to tell them to connect to the Wi-Fi. You don't have to ensure that they have a good internet connection. You don't have to have them to create an account. All you have to do is say, "Hi, welcome to the event. Here you go." And then you're in, right? Yeah. So the other half of this is the aspect. So in Bluetooth, if you've ever worked with Bluetooth before, there's two roles in Bluetooth. There's the peripheral side of it, and there's the central side of it. And the central side is in charge of scanning the device. And so, actually, no, this is really good because I can get into the actual setup of how we do everything. So how do we track? So let's say everybody's wearing one of these badges, right? How do we track who's in the room right now? And what we do is we actually set up what are known as bridges or hubs within the room itself to act as a proximity sensor. And so this hub is, its job primarily is to translate Bluetooth information into information that it can send eventually to the cloud. And so this information is then, so back to your question, is like how is this information transmitted? It's transmitted through these hubs that we place in every single room or whichever sponsor that we want to place it in. Another issue with iOS are MAC addresses, and MAC addresses are not, MAC addresses, if you're familiar with kind of wireless, yes?
Sorry, just a quick question
yeah.
at this point. Are you using triangulation or are you just using?
We are not using triangulation, because triangulation itself requires you to be in a set space for you to never move the hubs or the bridges or whatever. Because the nature of our business is the fact that we're always doing events. So once you place the hubs down, you have to take them out again. So we don't have the ability, or we don't have the manpower, or it's not even scalable for us to go to every single event and try to triangulate every single thing. So it's more as in, okay, we're not really doing analytics in terms of like, oh, where are you in the room, but rather, you were actually in this room at this time. Yeah, so no, we don't do triangulation. We actually just pull in the data, the fact that you're actually near this specific location. For iOS, there's another challenge in the fact that iOS is full of challenges. They say they do background scanning, they say they do background connection, but it's kind of a hit or miss thing. It really, like, once you put your iPhone to sleep, it's more as in like you're hoping to God that it can actually see anything that's around or connect to anything around. Another big issue with the power saving mode, as I said before, is another thing in Bluetooth is the fact that the information that's sent from this device is actually cut short, and it can't scan as frequently. And it also can't, because of a security issue, which is kind of really stupid at the same time, is that iOS does not allow for you to read the actual MAC addresses that are coming out of these badges. And so it's really hard for you then to identify exactly which badge this is. Somebody could be spoofing your IDs that you're sending out or things like that. And so it presents a hard problem in terms of iOS. It's like when you can't really know who is around you at that time. Next up is Android. I can cover Android as well. Android and iOS both have pros and cons when it comes to wireless technology. And for Android, it's really hard for us as Android developers as well, because Android has different hardware throughout its entire ecosystem. So you never know what chipset it's using for Bluetooth. You never know if it's actually Bluetooth itself was actually just developed for Android. There's one peripheral mode that was just recently introduced, and the Google official library for Bluetooth itself wasn't even officially introduced until a couple of years ago, I think. So as you can imagine, Android itself has so many challenges in terms of getting consistent performance. So if you guys are ever thinking about creating any type of wearable, any type of hardware device that depends on communicating with these mobile devices, that's something to keep in mind. It's getting better. It's definitely getting better, but it's important to be aware about these challenges. So yeah, wireless sucks. Wireless is something that it's wireless, right? So it's invisible. You can't really see it. It's hard to debug things that are in wireless, and you can't account for all of the different types of interference, all the different types of noise that will be in the area that you're going to be at that time. So I'm not sure if any of you have any experience in doing wireless development, but wireless itself is, so Bluetooth and wireless both operate on the same frequency at 2.4 gigahertz. Theoretically, they shouldn't interfere with each other, but it's not something that I've personally ever kind of proven to say, oh, wireless does not interfere with Bluetooth. It might not. But more of a problem is Bluetooth interferes with Bluetooth, right? And so when you have all of us kind of wearing all of these badges in a certain room, we have to see, how much interference, how many people can we see at the same time? We have to benchmark all of these different things, and they're all kind of communicating one another. And wireless itself, it's difficult because we're not only counting on Bluetooth technology, we're also counting on Wi-Fi, and so Wi-Fi at the venues is the Wi-Fi at the venues good enough, right? Just because somebody is kind of walking past you and then blocking that wireless transmission, will that throw you off? So these are all different kinds of questions that you're going to have to ask when you're doing wireless development, because it's really a pain in the butt because there's just so many things that you can't account for until you actually get to that environment where the wireless might be affected or it might not. Another problem with especially large-scale development is how do you test your hardware, right? And so if you think about kind of the size of events, there's 5,000 people, 10,000 people, how do you mimic that kind of surrounding? How do you mimic that kind of environment in order to make sure that all of your, everything's going to go well at the actual event? How do you mimic 5,000 people walking around with these different badges on them? And how do you mimic that kind of signal? So hardware test environments are a huge issue. And it's something that's so crucial and critical to get correct for you to actually have success when you actually deploy to production. And this is one of the lessons that we learned very early on, because every single time it would work perfectly within the lab, but once we got to the environment, once we got to the expo, once we got to the actual place, this would go wrong, that would go wrong, and we would have to actually debug on the spot, which creates a lot of pressure, especially when we're in different time zones. Time zone issue is a huge issue as well, if you guys are considering time zones and having critical applications like this. But we were like up all night in Taiwan trying to debug these things that were going on in California, New Jersey, and all over the world. We had events in India and things like that. And so our developers pretty much had to stay up 24/7 just to assist these events. And it was a huge pain. So hardware test environments are hugely important in terms of if you're going to have to develop these things in products, make sure you have a way to mimic the actual production environment. Manufacturing. So we manufactured in Taiwan with a company called, I'm pretty sure you guys have heard of Quanta. But Quanta helped us manufacture. I think this is just general in terms of hardware development. Hardware development really sucks. Like, how many people here have developed a hardware product from 0 to something before? Right. So not many, around 4. So I'm sure you can understand when you're doing something, especially if it's consumer facing, it's a huge problem to be able to get every single little point right. We've had so many problems just trying to get this to market. Like, even right now, like when people are wearing these things, they fall apart. They don't fall apart when we're working with them, right? But for some reason, people just come to us with these two halves of this badge. Like, one fell apart. It's like, how did you do that? They run out of batteries. How do you make sure that they're always the batteries are full? During the development process, different colors. It's a huge issue. So they're coin cell batteries, so very cheap batteries. Yeah, we replace them as well. And that's another thing, right? Our interns that are replacing these batteries, they're getting like burns after the at the end of the day, saying it's like you guys made this, you guys didn't make this very well. So it's yeah, their hands have blisters and stuff like that. And so these are all kinds of little things that you don't realize until the actual product is out, and then you realize, okay, now what do we do? And that's why hardware development is so hard, because you can't. It's not like a software process where you can keep on iterating on it. You have to say, okay, here it is, use it for a certain time, and then we'll come out with a version 2 of it.
How many revisions did it take you?
So we had multiple revisions of the same product. This is our second version, but we probably had around 5 or 6 different versions. I mean, there's a whole manufacturing process where they say you have to, at least with Quanta, I forget what the different stages are called, but they come out with the first phase where you prototype it, then you prototype it for a while, try to see if there are any bugs, and then you come out with the second version and the third version. And just keep on iterating in short batches before you go into mass production. So we iterated quite a lot on this one. There was an issue where we underestimated the height of a single capacitor component on here, and then the whole thing wouldn't go together. So that was a huge pain in the ass as well. So hardware. I mean, if you understand hardware manufacturing, you'll understand that these are all the things that you're going to run into when you try to do hardware development, especially electronics. Big data. Okay, so that was a hardware aspect of it. The other aspect of it is big data, right? So let's say now you have your hardware product. It's doing great, right? Everything is up to speed. Looks beautiful, it's transmitting a lot of data, but then you think, okay, what do I do to handle all of this data? And big data is like a buzzword that's kind of being thrown around these days, but really at the end of it is how do you process millions of data points that are coming in a second, right? And so this is something we've also learned really hard, is because when we try to just use it as, what, a standard startup company would do, and startup companies fail. Startup companies, the only problem with us is the fact that when we fail, it's in those 1 or 2 days that the event is actually going on. So it makes it even harder for us to say, oh, we failed. It's not like we could say, okay, well, we'll do better next time. But because at that point, the customer's already pissed off. And then it's like the entire event is gone because of you. But one of the issues that we had was there was so much data coming in, so much updating, so much inserting into our database. It started locking up our database. And that was really, really bad because, what was that? We've gone through multiple ones. Currently we use MySQL, and we're also using Postgres. We also use MongoDB as well.
But your own or like in a scaling cloud?
We scale on the cloud. I mean, we use cloud services for it. And even right now, right now we're to a point where we can insert documents. We're using MongoDB right now. We've migrated over to it. But the thing is, inserting data into a database is just one half of the problem, but calculating stuff from it is the other half of the problem. And so, okay, great. We solved one problem, right? We weren't getting any more database locks. And everything was inserting really, really well. But with millions of data points, now our queries are taking up to 10, 20, 30 seconds in order to execute. And to parse through all that data with our engine, it is taking up to 5 minutes in order to parse through all that data. And so now we're moving over to something that we're moving over to Apache Spark, which is more of a streaming service where you do streaming calculations as data is coming in on the fly. But this is all stuff that we didn't know before. We were thinking, oh, we could do this, right? In the end, we couldn't. So now we're hiring a data scientist in order to help us kind of scale this out and make it something that it can be a lot more robust. Constantly changing environment, I mentioned this before. The nature of our specific, and I'm sure if you ever want to do your own wearable, yes?
I have one question. What is data computing? Can you do it locally or you compute in the cloud?
In the cloud, yeah. We do some compression, we do some filtering within the hubs and the things that are there, but most of the calculations. So if you can imagine, all of these raw data points are being sent, and our documents are looking like, who, what time, where, and then like millions of these kinds of data, and then we have to parse it out and saying, okay, who is at the session, who is at this exhibitor, stuff like that. It takes a lot of computational power to do that. But yeah. We do that computation in the cloud, yeah. So one of our other challenges were the constantly changing environments, and I'm sure if you guys get into hardware development, you're going to understand this pain, because it's not only us, it's every hardware device that's out there. You make it into the lab, it works perfectly in the lab. Once you deploy it out into the field, it breaks down, right? So that's something that every hardware developer is going to run into. A lot of different factors, a lot of different issues. And that leads into my general hardware issues. The general hardware issues, which I mentioned before, is like they're falling apart. A lot of things that you don't account for. And I think it's critical in the fact that when you guys want to start doing hardware development, it's not like software development again. The software development is a little bit more lenient. You have to be experienced in order to deploy things to production. But with hardware development, if you get it wrong, you're screwed, basically, right? Because you've already manufactured it. You've already spent tens of thousands, hundreds of thousands, millions of dollars on product development, and when it's actually out, you realize, I put the leads on backwards or something like that. Something stupid, something so stupid that it's going to definitely be overlooked. Then when you realize it, then you're like, oh, okay, now we're screwed. My last slide is basically another thing that you're going to have to deal with when developing these kind of things is, are you going to do custom development, or are you going to use off-the-shelf components? And this is another aspect in terms of this we made custom, right? And a lot of people were thinking why don't you just take something off the shelf? at that point we were thinking, okay, maybe we should have done something. But at that point, no hardware device actually did something that we wanted. So that's why we had to make this entirely custom. But my one advice, if you were to do anything in terms of hardware, is try to use as many off-the-shelf components as you can. Because that's going to save you a lot of money and a lot of hassle in the long run. Well, maybe, or maybe not. Maybe their support's not going to be very good. Maybe you have the ability to do it yourself and you have the resources, which many don't, by the way. But yeah, so there's always the questions like, do we make this ourselves or should we just use something that's already existing? So yeah, that's the end of my talk.